Okay, so this problem was the spitwad problem. You were writing an equation for the data, and then you should realize that it is parabolic in nature because you are, something's going up in the air and then it's falling back down. You can also figure that out by plotting the points. And then we're going to write an equation for the data. So what I want to point out is you might think that the highest value is 60, and that must be the vertex. However, you should notice, based on these points, we are crossing the x-axis. If we have a height versus time equation, we are crossing the x-axis at 0, 0, and 4, 0. So the vertex does not happen at 1.5. It actually happens at 2. Another way to see that this is happening is like if you have 1 and 3, they're both at 48. So that's another way that you can think about this. So I'm going to write this in factored form. I think is the easiest way to do this one right now. I'm going to say this is y equals a times x minus 4. Because I know it goes through 0, 0, and 4, 0. Those are the x-intercepts. So I can set this up using factored form. But you could also have tried, you could have done this. It would have probably been more complicated in vertex form and just done a times x minus h squared, where the h is 2 and then plus k, and you would have had to solve for a and k. I'm okay with that as well, and you'd have to plug in several points and possibly solve a system of equations for that one. But I'm going to use the path of least resistance. I need to solve for a. I already know a is going to be negative, so let's make sure that happens. I'm going to plug in another point. I'm going to plug in 1 and 48. Okay. So 48 is equal to a times 1 minus 4. So that's 1 minus 4 is negative 3. Divide by negative 3. I get a is equal to negative 16, which does make sense because that is the value for acceleration. So for those of you who have taken physics, negative 16 should not surprise you. A does not stand for acceleration, by the way. I was just letting that be a placeholder. But negative 16 does end up being the acceleration. And I'll talk more about that for these next few. So y is equal to negative 16x times x minus 4, or negative 16x squared plus, let's see, 54x. 4 times 16? Nope. 64x. I can multiply. Don't you worry. All right, so that's my equation. Okay, so B/C, what is dHdt and d squared h over dt squared? What does that mean? So remember, you know what? This is supposed to be h. It's supposed to be height. And this is supposed to be t for time. I get so used to my x's and y's, But you are supposed to write this in terms of height and time. So go ahead and fix that if you haven't already. My bad, you do need to use h's and t's because it specifically says that. All right, so let's find the derivative with respect to time. So dHdt, just use the power rule. That's going to be negative 32t plus 64. And the second derivative, d squared h over dt squared, is equal to negative 32. All right, so I talked about, so this is the derivative with respect to time. So my original height is in feet. If you take the derivative with respect to time, you end up with feet over time, which is seconds. And then if you take the derivative of that with respect to time again, you get feet over seconds squared. So the derivative of height with respect to time, feet per second. So you should recognize that instantly. We've done these types of problems before. That is my velocity. And then negative 32 feet per second squared, that is my acceleration. Okay. So the derivative of your height with respect to time gives you velocity. The second derivative with respect to time gives you acceleration. So now let's talk about dH dt. Why is it always negative? I'm sorry, that's supposed to be dHd. I think the actual problem is d squared h over dt squared. Why is that always negative? So why is my acceleration negative? Well, okay, why do when we throw something in the air, why doesn't it just go off into space? Why does it turn back around at all? And that's because of gravity. Gravity is acceleration. What's gravity? I don't know. I'm very tired. My gravity is going to keep everything on Earth, right? If you throw it up in the air, it's not going to go off into space. It keeps it on Earth. So gravity is a negative force. Okay. It's constantly keeping things down. Okay. If it could, it would pull you all the way down to the center of the Earth. But the ground exists, so you don't go all the way to the center of the Earth. But gravity is always keeping you down. So gravity is a downward force. It's a downward acceleration. So that's why we always get negative 32. And that's why I said, like, if you've taken physics, the negative 16 in front doesn't surprise you. Because when you take the antiderivative of negative 32, you get negative 32t. And when you take the antiderivative of that, you get negative 16t squared. So your acceleration, when you go backwards and find the height function, you always end up with negative 16t squared if you are in feet, because your acceleration due to gravity is negative 32 feet per second squared. And it's constant because gravity doesn't change. Gravity is just always going to be negative 32 feet per second squared. Or if you're in meters, it's going to be negative 9.8 meters per second squared. So acceleration is the second derivative of your distance, right? And if you're talking about height specifically, gravity is the acceleration. That's what's keeping your spit wad, in this case, from going off into space. It's going to come back down because of gravity.